G'day everyone. So my name's Leigh. I'm a software engineer at the Stellar Development Foundation. And we're going to start with a question. So what is great developer tooling? So think about the tools and the products that you use every day. Which do you enjoy using? Which do you find yourself coming back to? What makes them great developer tools to use? So I think if we polled the room, we'd probably fill a whiteboard with a long list of attributes, everything from smooth user interfaces to great docs. And if we distilled all those ideas down into some common principles, we'd probably come up with something like this. Great developer tools are powerful and delightful. They give you access to everything that you need while making you forget that you're using a tool at all. In our time together, we're going to peer inside Stellar. We're going to discover some low-level features of Stellar that were crafted early to be leveraged by developer tools and developer products. My hope is at the end of this time that you will have discovered some capabilities that you could take into your developer products that would make them more powerful and more delightful to use. Even if you don't identify as a developer product builder or developer tool builder, my hope is that this would still spur some new ideas for you. So the features that we're going to talk about are contract specs, the Soroban environment, and XDR-JSON. Have you ever wondered how Stellar Expert is able to render these really nice views of contracts and their functions? So the interface being shown here is powered by contract specs. Now, if you haven't come across Stellar's contract specs before, they are Stellar's IDL for contracts. An IDL is an interface definition language. It's a way to define the interface of a program. And for contracts, that means defining the list of functions that you can call on that contract. Now, if you've built a contract for Stellar before, this might be really surprising to hear that Stellar has an IDL. And that's because you will have never seen it. It's true for Stellar, developers do not interact with the IDL. But that's unique in the world of blockchain. Many blockchains have their contract interface be a separate artifact that's generated at compile time. So you build the contract and you end up with two artifacts, the interface and the binary. For EVM, the interface is a JSON file that sometimes gets uploaded to IPFS. For Solana, the interface is also a JSON file that gets uploaded to the Solana network, separate to the binary. But this model has not played out so well. Earlier this year, Syndica stated that only 20% of the top 1,000 programs on Solana have interfaces published. The auditor Sec3 stated in response to that even for the contracts that have interfaces published, it's not uncommon to see these published IDLs be out of date and inconsistent with the deployed on-chain programs. If you follow crypto Twitter, you've probably seen some of these conversations about the status quo. People calling out how poor of an experience this is and calling for change. It is such a problem that developers are using IDL guesses to guess what the interfaces are of contracts that have been deployed. So Stellar has taken a different approach. Stellar builds the interface directly into the contract binary. It's not something that, as developers, you have to work with or distribute. It's just there, hidden inside the contract. On Stellar, contracts stand on their own on mainnet. The spec gets inserted automatically by the Soroban Rust SDK when you run the cargo build command, when you're building your contract. There's no separate process to generate the interface. There's no separate process to publish it. There's no second network to rely on. And there's no way to forget to update it when you upgrade your contract. So let's look at a real-world example of what a spec actually looks like. So this is the type of information you can expect to see in a contract spec. Function definitions, parameter names, parameter types, and documentation. In the Whisk network upgrade that just launched, there's even events as well. And this example is a real contract on mainnet. And this is not a rare event. 100% of contracts on Stellar have their interface published. That's not 100% of the top contracts, that's 100% of all contracts. This adoption is phenomenal. For developers building on Stellar, this gives you a rich definition of any contract, a rich definition that you can use to know how to interact with it and how to build on it. Let's have a look at how this practically benefits developers today. So imagine I'm building my contract. I'm using the Rust Sorbin SDK. I write a contract function called addLiquidity with its parameters and its documentation. I build, I deploy it, and I open up the terminal with the plan to invoke it. Now, at the terminal, I'm presented with a command line interface that's shaped by my contract. The Stellar CLI turns my contract into a CLI of its own with typed options dynamically generated from the contract spec at runtime. There's no code generation, there's no binding generation, there's no sharing of interfaces in separate files that you have to download from different places. The Stellar CLI creates this using only the contract ID. I want to give a shout out to Willem from the AHA company who contributed this functionality to the Stellar CLI that uses the contract spec. So next, I load up the Stellar lab. I paste in my contract ID, and in much the same experience, I'm presented with a dynamically generated interactive UI that's been built from the spec, given only the contract ID. I build a web application using the JavaScript Stellar SDK, and given only a contract ID, the SDK turns any contract into a runtime-generated client, where I can just call the functions like it's code. I load up the Freighter wallet to sign a transaction, and the transaction's displayed, the data's there, but it's been annotated with the contract spec, telling me what it means. And if I use the OpenZeppelin monitor to alert me to activity on my contract, I can configure it using things like function names, parameter names, that all come out of the spec, giving me a great experience of using that product. These are just a few of the ways that contract specs get used today, and they exist so that you can build products that are contract-informed. They're contract-informed user experiences. Now, if you want to use this in your application, you can use any of these one-liner utilities to get the contract spec out of a WASM. If you're using other languages, you can also just use a WASM parser or an XDR library. These things are easily to get access to. And then have a reader set 48, and it'll tell you what to do with these things. So next topic. Have you ever wondered how contract tests on Stellar run in a fraction of a second while still accurately matching how they get executed on chain? It's all because of the Sorbin environment, the contract runtime of Stellar. It exists as a Rust crate that's embedded into Stellar Core, the main node software for the Stellar network. So earlier when I invoked my contract, this is where it executed on-chain, inside the Sorbin environment, inside Stellar Core. But the environment was designed from day one to be usable in many more places than this. The environment is also used in the Sorbin SDK when you write tests. When I write this test for my contract, the env value, the end value created at the beginning of the test, contains the same runtime that's executing inside Stellar Core on the network. So as a contract developer, this gives me a ton of confidence that the behavior of my tests is going to match the behavior of my contract on chain, because it's running in the same environment. As a maintainer of this SDK, I spend 0 time maintaining a simulator, which is awesome. The Sorbin environment is also used in the RPC to perform transaction simulation. Now, when I say simulation, it's a bit of a weird word to use here because there's actually no simulator. Again, I'm executing the transaction, not on chain, on my local system, but it's using the same runtime. There is no simulator. In many blockchains, there's this divide between the real runtime that runs the network and the runtime that you see in simulators and test environments. But with Stellar, Sorbin was built from day one to service all of these needs. So products building on Stellar can also embed the Sorbin environment. And we're seeing some really exciting ways that developers in the ecosystem are using the environment in ways that we didn't imagine. So calling out Tommaso in Zyclu Labs, who's embedding the environment in Mercury to power indexing in, yeah, check it out. So there's so much potential to build some really powerful products because the runtime is so readily embeddable. And if you'd like to embed it in your application, you want to check out these two Rust crates, the Sorbin Env host and Sorbin simulation crates, and then take questions about this to the Stellar developers Discord, because the developers who build these crates, they live there. Last topic, XDR JSON. Have you noticed that the lab renders Stellar transactions really beautifully? So take a look at this screenshot. This is what the lab will give you if you give it a transaction. This is not how XDR normally looks. So let's take a look at XDR, and then we'll circle back to what XDR JSON is. So XDR is a binary format. It's defined in RFC 4506, and it's used by the Stellar network for everything. So it's used for transactions, consensus messages, events, data storage, everything. And the Stellar XDR is defined in this repo, this GitHub repository. The definitions are written in XDR language that just happens to really look like C code, if you're familiar with C. And all of the Stellar SDKs that you use to build on the network, they generate their code based off these XDR definitions. And XDR has a ton going for it. It's a very efficient binary format. It's a very simple binary format. The spec is actually readable, the RFC. It has no automatic forward compatibility. And this ensures that systems consuming transactions, they don't miss important details when new data is added to the network. Its encoding is deterministic, and that is really good for transaction signing and consensus message signing as well, because there's only one valid binary representation. But at the end of the day, this is binary. And as developers, we don't really want to look at binary, right? So let's see what I mean. So that command that we ran earlier with the CLI to invoke a contract, the CLI has this extra option we can use, -- build only, and it's going to give us the actual transaction that it's building and submitting to the network. So this is XDR base 64 encoded. It's not readable. The highlighted part is actually the function that we're executing, the add liquidity. It's not readable to me. It's probably not readable to you as well. If we decode the base 64, we can at least read the word add liquidity, but everything else is lost on us. So this is where XDR JSON comes in. So XDR JSON is defined in SEP 51. It is a formula for what any XDR value should look like when it's converted into JSON. The mapping supports lossless round-trip conversion, so every XDR value that is represented as JSON can be converted back into the exact same binary as it was originally. It works for the entire Stellar XDR library, all 433 types that are defined there. So let's have a look at how this creates some really delightful experiences. So imagine I'm back inspecting that transaction, and instead of just looking at the base 64 or trying to decode it into binary, I'm going to pipe it to the Stellar TX decode command. Now that command gives me back the transaction in the form of JSON. Now because the transaction is JSON, I have the whole JSON ecosystems of tools available to me to interact with this data. So I use tools like the JQ tool here, a popular tool for querying JSON, to extract out a specific field. Now imagine that I decide I want to edit this transaction before it actually gets submitted. The CLI has another command that I can pipe to called txedit. When I run this command, it's going to give me the transaction XDR JSON encoded, and it will have injected this extra line at the top. If you can see it, the $ schema with a URL. So that URL contains a schema of what a transaction envelope should look like in JSON. And editors like VS Code and Vim and any editor that support a JSON language server, they use this schema line to provide features like auto-completion, documentation, validation, and warnings. So here, the IDE is showing me all the possible values that I can use when hand editing this transaction. Now, if we move outside of the terminal, I open up Hubble, the Stellar BigQuery dataset, and I can use XDR JSON to query XDR values like the contract storage and contract events. Here in this screenshot, we can see that I'm dumping out the JSON, but BigQuery has great support for actually querying within that JSON, and it's very powerful. Chatting to my AI agent that's connected to the Stellar XDR MCP, I can ask questions about what a transaction does, and even ask the agent to make changes to the transaction or create entirely new XDR values. All of this is possible because the XDR MCP gives the AI agent XDR JSON and JSON schema, and agents know how to work with JSON really well. So XDR JSON, it's a great default for working with XDR in any product. It makes your product really interoperable with things like AI agents. It creates for a delightful experience when interacting with raw network data. So if you're building a developer experience, there's a really great chance you're going to touch on XDR. So you would benefit from using XDR JSON. It's available in 3 languages today: Rust, JavaScript, and Go, and hopefully more in the future. So to wrap up, we've talked about 3 features that exist on Stellar that you can use in your developer products to make them more powerful and more delightful to use: contract specs, the Soroban environment, and XDR JSON. I want to leave you with some code. So check out this GitHub repository after Meridian for examples for how to use all of these features. Thanks.